You'll type each letter's number key that many times to spell out the word, choosing which letters go on which key yourself. Up to 8 distinct letters per key. Your job is to figure out the best way to assign letters to keys based on how often each letter shows up, so that typing the whole word takes the fewest key presses possible. Beginner level, imagine your phone keypad, but you get to decide which letters go where. Arrange it the wrong way, and typing a word takes way more button presses than it needs to. Arrange it the smart way, and the total drops fast. By the end of this video, you'll be able to spot this trick in seconds. No prior experience needed. We'll build it up slowly together. Here's a simple way to picture it. When you pack a suitcase, the stuff you'll need most goes on top, not buried at the bottom, so it's easy to grab. That's the exact same idea behind something called Huffman coding, an algorithm real apps use to shrink files down so they take up less space. This isn't just a toy problem either. Amazon and Bloomberg have both asked versions of it in real interviews. Once you understand the pattern here, you'll start noticing it everywhere. Let's slow down and set up the problem from scratch. We have 8 keys on a keypad, and we get to choose which letters go on which key and in what order within that key. Here's the rule. The first letter you put on a key costs 1 push to type. The second letter on that same key costs 2 pushes. The third would cost 3, and so on. Our goal is simple: arrange all the letters in a given word so the total number of pushes is as small as possible. Here's a picture that might help. Think of a busy parking lot. The cars that come and go the most often should get the spots closest to the entrance, so people don't waste time walking. That's really all we're doing here. Step 1. Count how often each letter shows up. Step 2. Sort those letters from busiest to rarest. Step 3. And this is called being greedy. We hand out the cheapest, easiest keys to the busiest letters first. Don't worry about the cheapest, easiest keys to the busiest letters first. Greedy is as in, it just means grab the best option available right now. That's genuinely the entire toolkit for this problem. Let's start with the idea most people try first. Since every letter in our word is different from every other letter, no repeats, you might think the order we place them in doesn't matter at all. Just spread them across the 8 keys in whatever order they appear. And you know what? That actually works fine if you only have 5 letters. Everyone gets their own key. 1 push each. But watch closely what happens once we have more letters than we have keys. Here's the key insight, so pay close attention. Because every letter in the word is already unique, we don't need to worry about which letter is more important than another. We just need to know how many letters we're placing in total. What actually decides the cost isn't which letter it is, it's which group of 8 it ends up in. Think of the cheap, 1 push slots as a limited, precious resource. There are only 8 of them. So we should fill up all 8 of those cheap slots first, before anyone has to pay 2 pushes. In short, position. Where a letter lands decides the cost, not the letter it's identity. Let's make this concrete. Split all the letters into groups of 8, in order. The first group of 8 letters each costs 1 push. The next group of 8 costs 2 pushes each. The group after that costs 3 pushes each, and so on. Look closely at that 9th letter in the picture. It just crossed into the second group, so its cost jumped straight from 1 to 2. This is the big aha moment of the whole video. The total cost is just each letter's group number, multiplied by how many letters a group number. Let's trace through one full example together by hand. Take the word xycdefghij. That's 10 letters, all different from each other. The first 8 of them fit into our cheap group, so they each cost 1 push. That leaves 2 letters left over, and they spill into the next group, costing 2 pushes each. So we do the math. 8 letters times 1 push, plus 2 letters times 1 push, plus 2 letters times 2 pushes, which is 8 plus 4, giving us 12 pushes. That matches the expected answer exactly. Now let's turn what we just learned into a simple, repeatable recipe. Step 1. Count how often each letter shows up. Step 2. Sort those counts from highest to lowest. Step 3. Go through each one and multiply its frequency by its group number. To find the group number, take its position in the sorted list, divide by 8, round down to a whole number, then add 1. That's just a math way of saying which group of 8 is this letter in. That's the entire algorithm, start to finish. Time to turn this into real code. First, we use something called a counter. Think of it as an automatic tally sheet, exactly like the counting step we described earlier, to find out how often each letter appears. Then we sort those counts from highest to lowest, because the letters that show up the most should get the cheapest, easiest slots. This sets up everything we need for the next step. Now we go through the sorted list one letter at a time. For each one, we figure out which group of 8 it falls into. That's what integer division by 8s means. It just divides and drops any left over. And then we add 1, since the very first group starts at cost 1 not 0. We multiply that cost by how often the letter appears and add it to our running total. Once we've gone through every letter, we are done. That's the whole function. Let's pause here and try one ourselves. No code needed. Just the buckets idea from before. What do you think this returns for the word abcdefghi? That's 9 different letters. Take a moment, count them into groups of 8 in your head, and see if you can work out the answer before I reveal it on the next slide. Here's how it plays out. The first 8 letters fill up our first group, each costing 1 push. That's 8 pushes total so far. The 9th letter doesn't fit in that group anymore, so it spills over into the second group, where it costs 2 pushes. Add those together, 8 plus 2 gives us 10. That's exactly what our bucket rule predicts. Nice work if you got there yourself. Before we wrap up, let's talk about the approach you might reach for first if you didn't know this trick, trying every single possible way to assign letters to keys and checking the cost of each one. It would technically give you the right answer. But the problem is, even with just 26 letters, the number of possible arrangements becomes astronomically huge, far too slow to ever finish running. I'll admit, when I first saw this problem, I made exactly this mistake, trying to reason about individual letter placements instead of trusting the simpler bucket pattern. Let's quickly compare how fast each approach runs. Don't worry, this is easier than it sounds. Our sorting approach takes what's called n log n time, which just means it stays fast even as the word gets longer and it barely uses any extra memory. The brute force try everything approach takes factorial time, a way of saying it grows unbelievably fast. It becomes unusable after just a handful of letters. There is no real trade-off to weigh here. The sorting approach is simply better in every way. Let's double check a few special situations, just to make sure our approach still makes sense. If the word has fewer than 8 letters, every single one fits into that first cheap group. So the answer is just the length of the word, 1 push per letter. Also remember the problem, since every letter in the word is already different from the others. So our tally never counts higher than 1 for any letter. That keeps things nice and simple. And if the word is just a single letter, the answer is obviously just a single letter. The answer is obviously just 1 push. Let's bring it all together. Remember that 9th letter that suddenly jumped to costing 2 pushes? That one moment captures the whole algorithm, sort the letters by how often they appear, then group them into buckets of 8, and give the cheapest lots to the busiest letters first. You just learned a real interview pattern from scratch. Nice work sticking with it. A new video drops tomorrow at the same time, and we'll see this exact bucket trick again, dressed up in a much trickier disguise. If this clicked for you, that's exactly what the like button is for.